So for assignment, okay, you don't have to do software simulation for all. Okay, don't, not for all, only for one problem. So you only do softwares, you only do MATLAB for question 1. Question 1. Can you guys see the screen?
Yes, sir.
Yes, sir.
Okay. So this is given the differential equation, and that's the initial condition. This is the differential equation, dpq. Differential equation, sometimes you also can call it a dpq. And this is the initial condition. Initial condition. So what's inside here is called x naught. What's outside here is called y naught. And these are the initial points given to you. Without this, you won't be able to use the Runge-Kutta method. And you're given the step size. Step size is 0.5. Here in this case, you can call this h in this formula. So the formula, Runge-Kutta fourth order approximation. The iteration formula need to solve this problem. So we are going to try to solve this differential equation using Runge-Kutta method. The iteration formula. I just put RK for Runge-Kutta fourth order approximation. The general formula is yn h over 6 So make sure you remember this formula during the exam. You don't have to try to understand how the formula came about, just know how to use it. Let's say if I have to solve using the first iteration, so I put y1. Y1 is the first iteration. Okay, it's going to be equals to y naught, the given point, plus h over 6 k1 plus k2 plus 2k3 plus k4. That's a formula. So this is what we are trying to find, our first iteration. And that's going to be equals to y naught. Whatever is given, you give the current point to find the next point. And this is the formula h over 6 multiplied by k1 plus 2k2 plus 2k3 plus k4. And we will see what those k's are. K1. K1 is your differential equation. Okay, your K1 is your differential equation. We call this F your differential equation with the initial point plugged in. Okay, so the initial points are 0 for x and 2 for y. And then you plug that into the differential equation, which is 4 e to the 0.8 and then the x value is 0, and the y value is minus 0.5, and the y value is 2. If we calculate that, K1 will be equals to 3. Any question? Any question?
No, sir.
Yes? Any question? Huh? Any question?
No, sir.
No?
No, sir.
Okay, thank you. So that's K1. Then you find K2. K2, so you have to remember all these formulas is a function of the differential equation. You're going to plug in this formula. This time it's going to be not x naught, y naught, but x naught plus half the step size, and then y naught plus half the step size multiplied by K1. So that's going to be equals to f, your x naught we know is 0, h over 2, h is 0.5, divide by 2 is plus 0.25. Okay, so if you want to, so it's going to be 0. What was our step size earlier given to us was 0.5 divided by 2. Then what is the initial y value? Is 2 plus 0.5 divided by 2, and then multiply by K1. K1, you just calculated that to be 3. Something's happening with someone's mic. Some UFO trying to penetrate our lecture. Zero 0.5 divided by 2 is 0.25. And then 2 plus, in this case, 2 over here, 2 plus 0.25. 0.5 divided by 2 is 0.25. 0.25 multiplied by 3 is 0.75. 0.75 plus 2 is 2.75. 2.75, am I right? Yes.
Yes, sir.
Okay, then you plug this value into the differential equation that was given to you. So we have new x and y values, which is E, 0.8 multiplied by 0.25. Multiplied by 2.75 is equals to, you calculate using your calculator. So that's going to be 0.2 minus 1.375 is equals to 3.511. So K2, 3.5711. Any question? No question. I'll move on to K3. K3 is F, initial point plus 1/2 the step size plus Y naught plus H over 2, which is 1/2 of a step size multiplied by K2. Initial, the initial point is 0 plus 0.25, and then Y naught is 2 plus H over 2 is 0.25. And then K2, we just calculated that to be 3.511. So if you calculate this, 3.511 multiplied by 0.25 plus 2, so that's going to give you 2.8778. 2.8778. $2.8778. So now you have new X and Y values. Plug that into the differential equation. 0.8, 0.25 minus 0.5, 2.8778. That's going to give you 2. So that's K3. Similarly, you have to go ahead and calculate K4. Any questions so far? Any question?
No, sir.
All right, thank you. So the last one is K4. Is X naught plus H. So the last one has a different, is initial point plus the step size. Previously, it was the initial, for K2 and K3, it was initial point plus 1/2 the step size. But K4 is just the initial point plus the step size. Okay, please see the difference. And then here going to be Y naught plus HK3. See the difference between K2, K3, and K4? As you can see, there's no complex mathematics involved here. It's just playing with the numbers. 0 plus 0.5. Y naught is 2 plus H is 0.5. 3.447. Zero 0.5, 3.7235. Now you plug that into the differential equation, you can get 4e to the 0.4. Okay, sorry, there's a mistake here, slightly. 0.5. I'm skipping some steps here. In the exam, please do not skip any steps. If you skip the step and then you have the answer, and then it's something wrong, because this is an online exam, and people might be thinking, the grader might be thinking that you have simply copied from somebody. Okay. So 0.8, equation is 0.8 multiplied by x, right? 0.8 multiplied by 0.5 minus 0.5 0.5 multiplied by K3. Sorry, multiplied by Y. Okay, which is 3.7235. So if you don't know what you're doing, which equation I'm plugging into this equation. Those guys try to understand everything here and now. Don't tell yourself, okay, later on I'll do it. It's not going to happen later. It's now or never. You understand now. I'm going very slowly. You can see. I'm going very slowly. Later on, it's not going to happen. Here and now. For e to the power of 0.4 so K3, sorry, K4 okay, so any questions so far? So now you evaluate your Y1, plug everything in. The Y1 formula, you remember still? Y0 plus H over 6, K1 plus 2K2 plus 2, 2K3 plus K4. Y0 initial value is 2. Step size is 0.5 divided by 6. Step size is 0.5. Okay. And then K1, all these were calculated earlier. If you plug it in, punch it in, crunch it out, you'll get Y1 equals to okay, that's the answer. Which is 0 plus 0.5 in this case. Approximate Y when X is 0.1. The initial condition, let's identify which is the step size. It's a step size, AH. step size. This is the initial value, initial conditions. Initial conditions. And this is the differential equation. And this is the formula, general formula. So we are trying to find what is y value when x is 0.1. We're trying to find what is y value. Oh, sorry, what is y value? Right here, what is the y value when given the step size when x is 0.1, and also the initial conditions must be given. For example, if you are here, let's say this is the curve or something, and then you are given your x0 value. Your x0 value is given. This corresponding y value right here is also given, is 1. Okay. Then you're going to try to find what is your next value, y1. Okay. And that's what this formula is doing. So this formula is going to use the initial conditions given to find the next value. And this value is going to happen at x1, which is 0 plus 0.1, which is x0 plus 0.1 in this case. Which is 0 plus 0.1. Same thing. Any question? Same deal as before. We find what is K1. K1 is a function of the differential equation with x0, the initial points plugged in. The differential equation is quite simple here. So it's x0 plus y0. This is a differential equation. This is the differential equation. The differential equation. Now you define the differential equation as f x0 y0. The initial point is already there. It's very easy to evaluate this. Equals to x0 is 0, y0 is 1. So 0 plus 1. So therefore K1 is 1. Any question?
No, sir.
Yes, sir.
K2, using the formula f x0 plus h over 2 plus y0 plus h over 2. I'm going to go a little bit quicker because we already went through the same formula earlier in detail. So let me go through a little bit quicker. So x0 was 0, 0 plus the step size divided by 2. Y0 is 1 plus the step size divided by 2. And K1 was calculated to be 1. 0.05. 1 plus 0.5 divided by 2 is 1.05. Okay, so you plug that into the differential equation. X value is 0.05, Y value is 1.05. So if you plug that into the differential equation, it becomes 0.05 plus 1.05. That's going to give you K2 is 1.1. Any questions? No questions. Thank you. So next one, same formula, x0 plus h over 2, y0 plus h over 2, to multiply by k2, x0 plus h over 2, we calculated that earlier, right? So it's going to be 0.05. Y0 is 1 plus h over 2, h over 2 is 1 plus 0.05 multiplied by 1.1, K2 that you calculated earlier is 1.055. Okay. So you found your X and Y values. Now you plug that into the differential equation. It's going to be X value is 0.05 plus the Y value. This is a linear equation. It's quite straightforward to evaluate this. K3 is 1.105. Any question?
No, sir.
Okay, thank you. Okay, let's find K4. So please note that K4, the formula is slightly different. If we have x0 plus h, we have x0 plus h. Okay, here we have x0 plus h over 2. Here we have y0 plus h times K3. Here we have y0 plus h over 2 times by K2. So here we are using half the step size. Here we are using the full step size. So please note that if you make mistakes like this, there's no forgiveness. F x0 is 0, h is 0.1, y naught is 1 plus 0.1 multiplied by K3 0.1 1 plus 0.1 times 1.105 is 1.1105. Now you plug that into the differential equation. That's going to give you straightforward linear equation 0.1 plus 1.1105. So you find all the K's, K1, K2, K3, K4, and K5. Next, you take that and plug this into the Y1, which is the Y coordinate we're trying to find. Make sure you have all your formulas available in your mind. Should you guys have any questions? Got any questions?
No, sir.
Okay, we are almost done, but I would like to show you how to find the error. If you're told to find the error, then you have to find the exact solution. You can rewrite this as x prime minus y is equals to x. In this case, it will be in this form. Y prime px plus px y equals to qx. You can solve this using integration factor or maybe some other method. But in the exam, I may not give you something difficult. This is not really considered difficult, but still you have to remember your mathematics 1A probably. But in the exam, if I give you anything like this, it will be very straightforward integration. So to find the integration factor I, usually integrate exponent e to the power of the integral of px dx e to the power of px in this case is very clear. Px in this case, y is there. Minus 1 is px. So this is the integration factor. If you take this integration factor and multiply through by the differential equation that was given to you, that was available to you, that the one you plug into, we call this equation 1, and then this is equation 2. You plug into equation 2. Sorry, you multiply through the equation 2. So you're going to get y prime e to the minus x minus y e to the minus x is equals to x e to the minus x. So this is going to be e minus x y prime. I'm assuming you know all this. If you don't know all this, you can ask me to elaborate, or you can do your own research. why I'm getting this is because, let's say if I'm integrating this, the prime here is same as the d dx, dy dx, e to the minus x, same thing. So if you integrate, if you take the derivative of this, you're going to apply product rule, right? Then let's say if I apply the product rule, e to the minus x multiplied by the derivative of y, is y prime, plus y multiplied by the derivative of e to the minus x is minus e to the minus x. So e to the y prime minus y. So if you look at this and look at this, they're the same. So that's why it can be written in a compact form like this. If you do that, then you can integrate easily. You can easily solve the problem. That's the whole idea. Once you have done this, then what you do, you integrate on both sides. Integrate with respect to x. So when you integrate with respect to x, and there's already a derivative here, you have a derivative here, and now you have an integral here. Integral and derivative will cancel. Integral and derivative will cancel. You will end up getting e to the minus xy. On the right side, however, you have one term here, and you have another term here. They are a function of x multiplied together. So you have to do integration by parts. You can choose, if you remember the integration by parts, you have to choose your u and v carefully. So if you choose u, your x to be u, and db to be e to the minus x, then you will be able to integrate this easily. Okay. The formula is u dv is equals to uv minus v du. U dv, your v is minus e to the minus x, because dv is e to the minus x. Therefore, v is going to be, we integrate that, u is equals to x. Therefore, du is dx. Then you use this formula. Use that formula, and then you plug them all in. Minus x e to the minus x minus minus e to the minus x equals to minus x e to the minus x minus e to the minus x. So this is a kind of a lengthy integration. Most likely you won't get something like this in the exam because it will take a long time to integrate. So after integration on both sides, but I'm just telling you, if you are told to find the error, then you have to calculate the exact solution. Are you guys are still live online?
Yes, sir.
Yes, sir.
Yes, sir.
E to the minus x minus e to the minus x plus c on this side, because this is an indefinite integral. Because this is an indefinite integral. Indefinite integral means integral that doesn't have upper and lower limit. integral that doesn't have upper and lower limits, indefinite integral. So therefore, you must have a constant. Then you solve for y is equals to minus x, e to the minus x, minus e to the minus x, plus c. And divide by e to the minus x, e to the minus x, e to the minus x. So you're going to get y is equals to minus x minus 1 plus c e to the x. Which can be rewritten to make it look nicer. Then you need to find out what C is, right? From the given initial conditions. So you're given that when x equals to 0, y is equals to 1. So if you solve this, you'll end up getting C equals to 2. So once you have found your C, you go to that initial equation, then you replace your C with 2 e to the x minus x plus 1. So this is your exact, when I say this is an exact solution, this is the equation to find exact solution. Equation find the exact solution. At any point. In this case, if you are told to find at the exact solution when x is 0.1, to plug in 0.1, you get 2 e to the power of 0.1 minus 0.1 plus 1 e2 e 0.1 1.1. Let's use the famous calculator from the iPad Pro. Okay, is the calculation here? It's giving you 1.1034. 1.11034. 1.11034, which is same as, there may be some error. See, earlier on also you got the same answer, right? 1 point right here, numerical analysis and the exact solution giving you the same answer, but that doesn't mean they don't have error. The reason why this may have error if you include many decimal places. If you include many decimal places, then you can see error. Right now, we are only up to 5 decimal places. So if I ask you to calculate the error for 5 decimal places, error at 5 decimal places, of course, you know, error is 0. Right or no? Any question, guys? Any question?
No, sir.
Okay, in that case, I am done for today. If you have any question, you can WhatsApp me. Don't fall back. I'll try to. I've already given the assignment 1. I said your final exam will be assignment 1 and 2. But later on, I'll announce final exam. Okay, I'm giving you earlier final exam, Taylor series, Taylor series approximation. Runge-Kutta. Power method. You know what that is. Gauss-Jordan. Power method to find dominant, eigenvalue, eigenvector. Despite giving